Okay, physics and geometry. So we're going to start using vectors, and vectors can represent any number of things. So if I draw a line with an arrow, you don't know what that is. So it could represent displacement, it could represent velocity, acceleration, and we'll get to momentum. And later on, we'll get to other things. But what it is a vector quantity. So it means it has a magnitude and a direction. And a lot of times, especially in this section, so when we have something that's at an angle to, I don't know, something, I'll call this my horizon, that I'm going to want to separate it into components. So I want to figure out how much is pointing in one dimension and how much of that vector is pointing in another direction. So you want to think about vectors the same way you think about navigating, right? So I can walk between 2 points directly, or I can take an independent route. So I can travel further in one area and further in another area, and I end up in the same place. So 2 different ways. As long as I can add my vectors together head to tail to get to the same place, that I can replace them with that. So this is what we're going to be doing. We're going to be separating these. So I'm going to rely on 2 things to help me with this. So I'm going to have SOHCAHTOA, my Native American goddess of trigonometry. She's going to help me with figuring out what to do here. And then we'll have Pythagorean theorem when we don't know what else to do. So as a reminder, so sine of some angle is going to be my opposite angle over my hypotenuse. This is where the SO comes from. My cosine of my angle is going to be my adjacent over my hypotenuse. This is my COT. And tangent of some angle is going to be my opposite over adjacent. SOHCAHTOA, Native American goddess of trigonometry. So this is all you need to know really to get through this class, and the rest of the geometry that you might use is really just to change angles around. So let's do an example, right? So suppose I have this angle, this vector. We'll call it a velocity. We'll call it 20 meters per second, and this is at an angle of, I don't know, say 15 degrees. So this is going to be awkward, right? So I'm going to separate this into 2 dimensions. I'll separate it into a horizontal or x dimension, and I'll separate it into a vertical. So I want to know what is the velocity in my y dimension, and I want to know what my velocity in the x dimension is. And this is really important because velocity in the y direction is affected by gravity, and curiously, velocity in the x direction is not affected by gravity. So this is going to be constant velocity, and this is going to be experiencing acceleration. So we'll want to separate it. So here's what I'm going to do. So this one is the opposite. So I'm going to use my sine. Right? So my sine of my angle is going to be my opposite over my hypotenuse. I want to solve for my opposite, so I'm going to multiply both sides by hypotenuse. So this is going to be my hypotenuse times the sine of my angle, or 20 times the sine of 15. The x is going to be my cosine, so I want to get to my cosine of my angle. So I get here by saying cosine of my theta. This is going to be my adjacent leg, which I'm interested in, over my hypotenuse. I'm going to solve for hypotenuse. Solve for adjacent, so multiply both sides by hypotenuse. So v of x is going to be equal to my hypotenuse times the cosine of my angle. Right? If you remember this, right? So the y dimension, or my opposite leg of my triangle, is my hypotenuse times the sine of the angle. My adjacent is hypotenuse times the cosine of the angle. Right? That's like 85% of what we'll need to do in this class. So hang on to that. So we're going to have to separate these. I know I can plug in some numbers here. So this is going to be 20 times the sine of 15. And through the magic of my super fast calculator, which I already did this, so this one's going to be 5.18. And this one is going to be 19.3. And this is velocity, so it's going to be meters per second. It's going to have the same units as my my hypotenuse. Okay, so we can check this, right? So how do we check this? Well, we can use the Pythagorean theorem to help us with that. So our Pythagorean theorem, so this is the last thing that you need to know from geometry. If I have 3 legs of a right triangle, it says that c squared is equal to a squared plus b squared. So let's check to see if we get back to our hypotenuse. So c is going to be equal to the square root of a squared. So I don't know, I'll call that 19.3 plus b squared, I'll call it 5.18. And let's see what we get. So quick. So I'm going to take the square root of 19.3 squared plus 5.18 squared and see, and I get to 19.98. So darn close within my rounding error. So I'm feeling good about this, meters per second. So these are the two things that we're going to use. So we're going to use SOHCAHTOA and Pythagorean theorem to dissect angles. Pretty much whenever you see a vector that's at an angle to something, odds are you're going to have to separate it into x and y components, and that's always the first thing you want to do. Hope that's helpful. Talk to you soon. Bye.